Dear children, look at the video shown on the screen. There you can see that our Ballala Deva, what he's trying to do. Yes, look at that. Their very strong buffalo is in motion, right? Then to stop that, what Ballala Deva is doing? Yes, he applies the force in a opposite direction. Yes, with this we can see that force can bring the bodies from motion to rest. And in this case, you can see that a person is kicking the ball. Before it was at rest and now the ball is coming to the motion. So with this we can say that force can change the state of rest, means from rest to motion. And here you can see that the great King Virat Kohli, what he's trying to do? Yes, he's hitting the ball. Of course, it is true only. But the ball is coming towards him, but with the help of bat. The moment when the ball is hit, okay, what happens? The direction of ball is changed. So in this case, we can say that force applied on the moving body can change its direction. And literally, in this case, you can say that the force applied on vertically, you can say that the moment when you can apply the force on vertically, what happens? The clay shape is changed. So with this we can say that force can change the shape of an object. Hello dear children, how are you all? Hope you all are fine and doing well. Yes dear children, in today's class we will be starting the laws of motion chapter. Of course, we had uploaded one short video on laws of motion. Link will be given in the description. Go to that video, but only for revision purpose. So this is a high time to discuss laws of motion. It's a unit wise, it's in detail. So before going to discuss this chapter, before going to start our session, let us see once again how many units we have in this chapter. Dear children, we have almost 5 units. So by listening this, you won't get tensed, right? Don't get tensed. It's a small topics only, of course, but don't worry, be with us. We are going to make the concepts very easy. Dear children, mainly in unit A, we will be talking about the contact forces, non-contact forces. In a unit B, we will be discussing about the inertia, types of inertia. There only we discuss about the law, what we can say Newton's first law of motion. In a unit C, we will be talking about the Newton's second law of motion. There in detail discussion we have, and the applications of Newton's second law of motion. In a unit 4, that is my unit D, we will be talking about the Newton's third law of motion. And finally, in a unit E, we will be talking about the gravitation. There only we are going to discuss about the Newton's universal law of gravitation and the relation between acceleration due to gravity and universal gravitational constant. And finally, we will end the session with the mass, weight and free fall. Okay, fine. Okay, now let us just come back to the today's session. Of course, you are with us only, right? So you are in the same session. Okay, so in this particular session, let us see. To say what is today's exactly agenda. Did you look at here? So we are going to discuss about actually what is a force, impacts of the force, what force can do. Then we talk about the contact forces, non-contact forces. Okay, yes teacher. So what are the impacts of the forces? What force can do? Of course, I think you may feel that, sir, beginning of the video we have seen. Yes dear children. So whatever you have seen, yes, those are the impacts of the forces. That is what actually force can do. But still, let us list out one by one so that we will have more clarity. So impacts of force. So dear children, be ready with your notebook and pen so that you can note down some important points. Okay, fine. So first we will be talking about the impacts of force, or else what force can do. So here, force can, what force can do? If any object is at rest, you apply force, then what happens? The body comes from rest to motion. So then can we say that force can change the state of rest? Of course. Okay, so force can change the state of rest of an object. At the same time, dear children, just you think that you are going in a vehicle, suddenly something came across. What will do? We apply force. So in that case, of course, we apply the brakes. We apply the force on the brakes. Okay. So applying brakes means what? Applying force means together. We have to apply the force on the brakes. Then what happened? Car is stopped. A vehicle is stopped. Means before car was in motion. The moment when you apply the force, it is brought to the rest. So we can say that force can change. Force can change the state of motion. State of motion of an object. Okay. And of course, I know that sometimes you'll be playing in the class with the rubber bands. Some of you may play in the presence of teacher. The moment teacher will turn the back or towards the board, we'll be playing with a rubber band and just hitting the friends. Of course, don't do that, such things. Okay. So the moment when you try to stretch the rubber band, there you are applying force, right? Of course, yes. They be children. The moment when you apply the force, what happens? Its length is changed. I mean what? Dimensions are changed. Even you can take a normal tennis ball or else rectangular paper you can take. When you try to apply some force, the shape has been changed. Let us suppose you are going on a vehicle. There will be a U-turn. What we will do? We will apply force on the steering wheel so as to change the direction of vehicle. Let us list out all these things also. So here, third one, it can change the shape or size of an object. And fourth one, force also can change the direction of an object. So this is what actual force can do. So with these children, let us define what actual force is. Dear children, force is, simply we can say that it is an external cause. Which can change or tends to change. Okay, so it is an external cause which can change or tends to change the position, that is the rest, motion, shape, size and even direction of an object also. But dear children, whenever force acting on object, you need to think one important thing. Is the force acting on rigid body or non-rigid body? You may get to doubt, sir, what makes the difference? Let us see here. First, suppose, dear children, here is force. Okay, so force, if it acts on non-rigid body, okay, let us say that force acts on rigid body. So rigid body means like a stone. Of course, strictly speaking, there is no perfect rigid body in the universe. We can say, ideally we can say diamond is a rigid body, but still it can be damaged. Okay, fine. So non-rigid body, like a duster, spongy duster will be there. Okay, now for example, if it is not fixed, you are applying a force, what happens? It will have a reclining or it will have a translational motion. But if it is fixed, you apply force, then what happens, dear children? Its shape is changed. Yes sir, no. Yes, its shape is changed. Shape is changed. But if the force acting on a rigid body can change its shape? Of course, no. First of all, rigid body itself is what, dear children? The body in which the distance between any two pair of particles is not changed with the application of external force. It won't change. If it is free, it is not fixed. Let us say if it is not fixed, you are applying force, it will have a translational motion. It has translational motion. If it is a fixed, if it is a pivoted at one end, another end if you apply force, then what happens? It will have a rotational motion. Of course, shape can be changed. If it is not free, if it is not free, shape is changed. If it is free, of course, it also will have translational motion. This translational motion is the common. So these are the actually impacts of the force. Now, dear children, let us think about the types of forces. So from the point of what we can say application, okay na? From the point of application, okay na? So we can divide, the children, forces into two categories. We can divide force into two categories. First one is contact forces and second one is non-contact forces. So let us discuss first contact forces. Contact forces. The children, the name itself will give you the concept. What is that? Contact means what? Physical touch. Physical touch is needed, means these forces can act by means of physical touch. The forces which can act by means of a physical contact or physical touch are called contact forces. I think in a class 6 also you had learned about the muscular force. If you want to lift something, of course muscular force is needed, but don't get there you are holding. Yes, we are holding. Of course, in all types of contact forces, maximum when we involve, where we are involved, then muscular force is involved actually. But that was in a class 6 discussion. As per the class 9 children, yes, first one we will be talking about the frictional force or force of friction. What is that? Frictional force. Frictional force. Yes, dear children. So if you want to think something like this, so as we know that force can make the objects to move and force can make the object to stop even. Okay. For suppose, dear children, let us say here is a surface, let's say earth surface. Somebody is playing with a ball, let us say that, and it is thrown on the earth surface. So it will move. It will move in the sense, do you think that it will move continuously from one state to another state, one country to another country like that? No. Reality. Of course, as per the concept of force, we know that, sir, just we have thrown and nobody is applying force later. Then it has to continue, right? Because we know that force must be there to stop it. But after some time we are not applying force, but still ball will be stopped. Which means what? As ball is stopping means what? You should understand, I should understand, we all should understand that there will be force acting in a opposite direction. Yes, very important. That force which is acting opposite direction of motion is a frictional force. Frictional force is always the opposite direction of motion. It always opposite the motion. If a ball is going left to right, the frictional force will be right to left. If a ball is going from right to left, the frictional force will be left to right. You may doubt, sir, what happens if a ball is coming top to bottom? Hey, friction will be bottom to top. That's it, quite opposite. Always opposite the motion. Here, yes. So which means what here? Here is one body. Okay, now one ball or a body, anything you can take. Means here what is happening? This body has a motion in this direction. So with respect to the earth, it is moving. Means there will be some relative motion. Whenever there will be some relative motion, a kind of force will come into picture, which always in the direction of opposite, or in the direction of what? Opposite of motion. In the opposite direction of motion, and which always acts along the surface in contact, means in this direction. So this is a direction of frictional force. It is a direction of frictional force. So frictional force always unitary, but it always opposes the motion, and it is along the, what is this direction? It is along the surfaces in a contact. Surfaces in a contact. That's it. This much is enough. Okay. Clear? Means the condition, there must be some relative motion. Whenever there will be relative, means one body is like a moving over the other body, means there must be some two surfaces should be, there should be some relative motion. Then this force will come into the picture. Usually what it will do, it will try to stop the body because it is in the opposite direction of motion. Clear? Fine. And the second one is normal force or normal reaction. Normal force or normal reaction. To understand this, the best example, dear children, let us take something like a table or any horizontal surface. Okay, like a table, like you can take just, okay, for understanding purpose, for just understanding purpose. Okay, let us say something like a table, and here one book is placed. Okay, some book is placed, let us say that here some book or block is placed. The point is that, dear children, Do you think there's some force acting on the body? Of course, without hesitation, we all will tell that yes sir, there will be a force of gravity. Yes, that is nothing but the weight only, right? Yes, of course. So, of course, weight of the body will act. Gravitational force acts a downward direction. That's clear. But dear children, whenever force is acting on a body, must change its state, right? Please try to understand. Here, the body is placed in the table and force is pulling it downward direction. Then why that block is not going downward direction? Body is at rest, which means what? Net force acting on the body is 0. For suppose here downward direction, some 100 newtons is acting. But still the body is not moving. Children, when the body will move, when the body will move, there must be some net force. Means here, the net force acting on the body must be 0. So, net force means this force should be 0. To have this force 0, there must be one equal and opposite force. That only we can call it as a normal reaction. These two forces are equal in opposite direction. Then the net force will be 0. Right? Very important. Means here, okay, let us not talk about net force, again you will get confused. Okay, let us not talk about the net force. So simply let us say that why this body is not going downward direction? Because try to understand. Here, this block is exerting force on this table which is equal to the weight. Similarly, this what we can say table surface also exerting force vertically upwards. This force which is acting on the block by the table is called normal reaction. It's called normal reaction. So hope with this it's very clear for you, right? Okay. Now let me give one question. So with this it's very clear that yes, it is force is downward direction, that is the weight, and a normal direction is upwards. The children, for suppose here this kind of block is there, this kind of surface is there, like what we can say wedge type, not wedge. This type of surface is there, and here block is placed. Okay. Now the task is in which direction weight will act, in which direction normal reaction will act. Okay. I think just try it here. Just try. Let me tell you. So just try to put on paper, and now I am going to explain. Just compare. After that, just you tell whether you got right or wrong. Okay. See, weight is always downward direction. No doubt, weight is always downward direction. Weight, that is mg, is acting downward direction. So by seeing with this reference, so it is also weight only. With this reference, many students will think that, sir, exactly opposite to the weight, normal reaction. They'll think in this direction. This is a normal reaction. They will think, but it is wrong. It is wrong. See, normal reaction is not opposite to the direction of the weight, dear children. Then what, sir? Let me tell you. Yeah. Come on, wait. Yes, this is contact, right? Surface is in a contact. Normal reaction is always perpendicular to the surfaces in a contact. Here also, this is a contact, right? So you can see here, this normal reaction is perpendicular to the surfaces in contact. Here also perpendicular. So normal reaction is always perpendicular to the surfaces in a contact. Clear? Okay, fine. So the second one. Now the third one, dear children. Tension. Sir, we have so much of tension. Exams are coming, sir. How to handle? Dear children, whatever the tension you are feeling is quite different. The tension, whatever we are going to learn, is completely different. Okay, hey, why tension, man? See, this is what actually, keep on telling to all students. Hey, don't take tension. Try to do your work. Do your best. Leave the result, ma. Leave the result. And some students, top students also have seen that they are getting tensed because they want to get a top. Let me tell you one thing, dear children. If you are in game also, don't play just to win. Don't try to play to win. I want to win. No. The moment when you feel that yes, I want to win, I want to get the rank, so much of stress, pressure will be there. Do the things properly. Work hard properly so that you should win. Difference is there. Don't play the game just to win. You play your own game so that you should win. That's it. Don't take a pressure. It's not like I must win. sometimes plus or minus marks will be there. See, the life itself is like, it's like a rectifying mistake and moving forward. If you are getting the best results, I'm very happy. But don't get nervous. Don't feel bad. Try your best. But just check, are you putting your sincere efforts? That's the matter. Okay, dear children? Clear? Don't have a tension. Have the tension in physics. Have the tension in physics, but not in your life. Okay? Fine. So, tension. Dear children, here is, let us say that here is a rigid support. Here is what is rigid support. Here one body is suspended by means of a string. The means of a string. So obviously it has, let us say, mass m, and we know that there will be some gravitational force acting on that. That is called weight. We'll try to pull it downward direction. Try to pull it downward direction. But you tell me, dear children, though weight is pulling this body downward direction, why it is not going downward? Which means what? Somebody is pulling it upward, right? Somebody is holding it, right? Yes or no? Try to understand. Logically think. Though gravitational force acting on this body, why this body is not going in downward direction? Because it is attached to the string, and the string is stretched. In a stretched condition, string will apply force. In a stretched condition, a kind of force is developed. That force only we can call it as a force of tension or simply tension, which will be acting upward direction toward the point of suspension. Toward the point of suspension is the tension T. And remember that, dear children, tension is always pulling force. Pulling force. It is not a pushing force. You may get not, sir, how, sir? Okay, I'll tell you one thing. You take one block or one chair, you just tie one thread. With the help of the normal thread, will you push the table? Will you push the object? No. You only can pull that. That's what I said here. Tension is always pulling force. It cannot push. Okay, so this diagram is a very important examination point of view. Very, very, very important. They may give you just normal without these directions, forces. They'll give this diagram and they'll ask you how many forces are acting on the body which is suspended by means of a string, and show the directions. So tension is acting vertically upwards and the weight is acting vertically downwards. Clear? Fine. Now, okay, I need a space case. Can I erase this? 3, 2, 1, please. Okay, now done. Fine. Spring force. Fourth one is what it is? Spring force. Fourth one is spring force. Okay, yes, spring force. For suppose, dear children, let us take 3 conditions. Here is spring in a normal condition. Spring in a normal condition. Let us say here. Now let us say spring is compressed. Compressed till here. So it is a compressed state. Try to understand. Compressed state. Next condition is that, let us take that. So it is stretched. Okay. So it is a stretched condition. It is like in a stretched condition we have taken. So to compress or to stretch, some force must be must act. The force must act. But in this case, in which direction we would have applied force? Yes, here in this direction we applied the force in this direction. Let us say F external force. External means the force what we are applying, and here to compress this force acting. But try to understand the moment when spring is compressed. Before it was here, right? Yes, now here it is. So this is this much it got displaced. Okay, na? Am I clear? Yes. And here also, if you can see, ting. Yes. So this much it got displaced or elongated. Compression. Here it is. We can compression. It is elongation. Try to understand. But children, one thing. If you apply more force, more will be the compression. If you apply more force, more will be the what? Elongation. It depends. Either compression or elongation is nothing but the displacement of the spring already. It depends on the external force. But dear children, when you compress the spring and after some time just try to leave it, what happens? Do you think that spring will be in this position only? No, it will come back to its original position, which means what? The moment when we are trying to compress or elongate, when we are stretching or compressing, the moment when you start applying force only, a kind of force will be developed in the spring. It will try to regain the original shape and size of the spring. That force only we can call it the restoring force or spring force. Spring force. Okay, this is simply it's a spring force or what? It's what? It's a restoring force. What is the direction of restoring force, ma? Yes, it always opposite to the direction of external force applied. In this direction, you will try to take the spring back. What is the restoring force, dear children? The force which will bring the body to its original shape and size is called restoring. Its original shape is restored, its original size is restored. Such a force developed in the spring only we can call it the restoring force. Of course, we also can use this. We also can use as a spring force. And remember that, dear children, the magnitude of the restoring force is equal to the external force. You apply 1 Newton, it will be 1 Newton. 2 Newton, 2 Newton. 3 Newton, 3 Newton. Very important it is. Okay, try to understand. So, the amount of force which we applied is equal to the force developed in the spring. Force developed in the spring means I can say that the force is, see, this force is proportional to the x because this force is equal to this, right? More force, more displacement. Less force, less displacement. These two are equal in magnitude. So then I can say restoring force is proportional to the displacement. Means it might be compression or elongation, but in a opposite direction. That's what I put a minus here. So the spring force is always proportional to the either elongation or compression, but in opposite direction, because displacement will have in this direction, force is in this direction. Yeah, displacement is in this direction, but restoring force is in this direction. So here only, this only we can write as simply, okay, restoring force or spring force, anything we can write minus kx. So k is what here? Spring constant. K is called what actually? Spring constant. It depends on the nature of the spring. And dear children, this is the principle of working of spring balance. In higher classes, you will be learning this as a Hooke's law. Is the point clear? Fine. So with this, we have done the fourth contact force. And next one, the last one is what? Forces during the collision. Forces during the collision. Collision means what? Indirectly, of course, in a regular life, accident. Of course, let us not wish to happen such kind of negative things. Okay, na? Accident. Simply colliding each other, two bodies. So during the collision, obviously, what happens? Either means let us talk about in terms of vehicle. Car is hitting a scooter is hitting the car. Of course, more damage may happen for a small vehicle due to the momentum and everything that will be learning later. But though it is for example, it is a big body, very much big body is coming like this. Let us say body A, small body is coming, and both came in contact, B. But still, small body may get damaged more, may get more damaged. But still, dear children, here body A apply force in this direction, FA. Body B also will apply force, FB in this direction. Still, it will apply. So during what we can say collision, dear children, huge force will act in a short interval of time. It's not like in a movies they'll show, it's like a slow motion coming, hitting. No, it's not like it happened. Dignan road, if a car is coming and a scooter is coming, hey scooter, I'm coming and hitting, coming. That much cinematic won't be there. Just coming, just hitting. Means during these collisions, a huge force will act in a short interval of time. Okay, fine. So dear children, so these are the types of contact forces. Okay, copy? Can I do this? Yes. Now children, we will discuss about the non-contact forces. So examination point of view, children, in the contact force, if they want to ask you the question, they will focus more on tension Next, normal force, then frictional. Just I'm guessing. Okay. And the second type of forces are what? Non-contact forces. Non-contact forces. Non-contact, or we also can call it as a field forces, or we also can call it as a forces at a distance. Forces at a distance. Forces at a distance. At a distance. Why are we calling these many? What the names will tell. First of all, non-contact. So these are the forces which can act, but physical contact is not required. Physical touch is not required. For suppose, let us take, here is a marker only. The moment I will leave this one, yes, it is going down. Going down means what? Somebody is pulling. Who is that somebody? Earth. Means here earth is pulling, but still there is no contact. That's what I'm telling you. So these forces can act, but here contact is not at all needed. Under this non-contact forces, we are going to learn three forces, dear children. First one is gravitational force. First one is gravitational force. Gravitational force. So we know that if you try to throw bodies upward direction, but make sure that you are not throwing the bodies with 80 km per second. What happens when you try to throw body with 80 km per second? I think body will go and will settle in earth orbit. If you try to throw body with 11.2 somewhere kilometer per second, then body will escape out of this gravitational force. Not that much. We don't throw. In general, I am talking. So whenever you try to throw any objects upward direction, still they will be attracted towards earth only due to the gravitational force. And remember that, dear children, gravitational force is a long range force. It is long range. It can act between all celestial bodies. You can take any two bodies anywhere in this universe, still there will be some gravitational force. Okay, and you know one thing, among all, it is a weakest force in the nature. Weakest force in the nature. Of course, regarding this you will be studying, but just remember, weakest, you don't believe, but still it's a weakest force. Long range but weakest force. And here, can I say that, Acha, have you seen any time there earth is pushing the bodies upward direction, repulsing? No, always attracts. So here gravitational force is always attractive in nature. Always attractive in nature. And one more important thing is that it always acts vertically downwards. Vertically downwards. But dear children, what is the responsible for this gravitational force? Yes, mass is the responsible. Mass is the responsible for this gravitational force. Whenever there is a mass, there will be a gravitational force. So if you can take some mass, around the mass there will be some field is created. Field is created. This field around this mass only we can call it as a gravitational field. In this gravitational field only gravitational force can act. Means if any object will come into this gravitational field, it experiences force. That force only we can call it as a gravitational force. Here I said field forces. Why we said? Because if you can take a mass in around this, some field is created. Of course, to communicate we are using a language, but how both masses will communicate? How? Do they have any special language? No. They will communicate through the fields. And these forces can act at any distance, long distances, right? That's why we can call it as a force at a distance. Now you got a clarity? Yes? Okay. Always. Now, second one, dear children. Second one, magnetic force. It is magnetic force. Magnetic force. Yeah, the first one, what we can say that, yes. What is the responsible for this magnetic force? Here the magnetic pole. What is that? Magnetic pole. The forces between the two magnets is we can call the magnetic force. But if you are bringing this to similar poles, like poles, will get repelled. Unlike poles, attracted. So which means what here? Magnetic force may be attractive, attractive or repulsive also. Attractive or repulsive. And as you are moving far from the magnet, the magnetic force will be decreasing. Same thing happens with this gravitational force. As you are moving far from the earth or far from the mass, the strength of the gravitational force will be decreasing. Clear? Fine. And the third one is electrostatic force. Electrostatic force. Electrostatic force. Yes. So in a class 6 you had an experiment, right? So you take a pen and just try to rub against your dry hair so that it gets the ability to attract the piece of paper. That is because of what, children? Electrostatic force. Then what is the responsible for this electrostatic force? Yes, here is a charge is the responsible. Charge is the responsible. Charge is the responsible for this. Yes, here also positive charges will get repelled, negative charges will get repelled, but positive negative will get attracted. So which means what here? Electrostatic force also may be attractive or repulsive. It depends on the polarity. Repulsive. So dear children, even this electrostatic force also, as you are moving far from the charge, the strength will be decreasing. Dear children, so these three comes under non-contact forces, that is similarity. So what is the similarity in exam ask? These three are contact forces. Second similarity what? Either magnitude of the gravitational force or a magnitude of the magnetic force or a magnitude of the electrostatic force decreases with the distance. As you are moving far, the the strength of the force keeps on decreasing. But one difference is there. What is that? See, these gravitational forces differ from these two. What way? Gravitational force is always attractive in nature, but whereas magnetic and electrostatic force may be attractive, may be repulsive. Okay, so in exam they may ask you, write the characteristics of the non-contact forces. You can write this. Yes, gravitational force is always attractive, but whereas magnetic and electrostatic force, they may be attractive or repulsive. And second one, the magnitude of the non-contact force changes with the distance. How? As the distance increases, force decreases. And the children examination point of view, one question can be most wanted question. If my guess is right, in all schools, all teachers may test this question in exams, might be UTs or term exams or annual examinations. Look at here. What is that? I'll tell you. Can I erase this? Can I? 2, 1. Yes. Okay. So you can take, see, to explain this concept, I am taking two masses. You can take two charge, two poles. Anything is okay. Okay. First, the children, let us see here mass M1 and here is mass M2. Let us say both are separated by some distance r. Children, always distance you should take from the center to center. So if I'll say r, you may get confused, some of you. So let me write d, distance d. So definitely there will be a force. There will be a force. So this force, how is related to the distance is the matter. So the magnitude of the non-contact force is inversely proportional to the square of the distance, separation distance. So this only, if you want to compare, so it can be written F1 by F2 is equal to D2 square by D1 square. Okay, look at, now I'll tell you the use of this formula. For suppose here it is a M1. So in this case, let us say that in this case, okay, and the simple thing is that, so here force is, let us say some 10 newtons, actually 10 newtons. Now if distance is doubled, then what will be the new force? Let us say this force F1. Please try to understand. So let us say when both mass are separated by distance d, the attractive force acting is 10 newtons. Now this distance is doubled without changing the mass. The distance is doubled. Then what we know that when a distance whenever there is change in distance, definitely force will change. But how much? Look at here. So let us take this equation, this formula only. So in a first case, so F1 means, yes, let us take a 10 Newton, F2 to be calculated, D1 is a D, D2 is a 2D double. Substituting this, that is 10 by F2 is equal to, so D2 square, which means 2D whole square, 2D whole square, which means what? 4D square by D square. D square get cancelled. Now do the cross multiplication, we will get a 4F2 is equal to 10. Then F2 is equal to 10 by 4. Of course, we can simplify this, but just keep it like this. I'll tell you why. Okay. And if in the same situation, if D will become half. If distance is halved, if this distance is halved, let us say till here only. The distance is halved. Then what will be the new force acting on it? Same thing, everything is same. Now distance we are making it a half. So now same formula you can use. So initial force how much? 10 by F2 is equal to D2 square means what? D by 2 whole square by D square. So this will be D square by 4 by D square. D square get cancelled. This 4 will come to the denominator. Now 10 by F2 is equal to 1 by 4. Do the cross multiplication. F2 is equal to 4 into 10 Newton. Of course 40, I too know. But let me tell you one conclusion here. What is that? Whenever, dear children, distance is doubled, force will become 1/4 of its initial value. 1/4 means force will be decreased by 4 times. Whereas when distance is halved, force is increased by 4 times. Means in this case I can say new force F dash is equal to initial force by 4. In this case, let us say new force F dash is equal to 4 times of 4. This see, whenever in a exam 1 mark, if it is asked 1 mark question, you can use directly this question. Means if a distance is halved, what is the force? Some initial value given, right? Multiply with the 4, you will get the answer. Whereas here in this case, if a distance is doubled, then force will become 1/4 of its initial value. Is it clear? Fine, dear children. So this is what actually unit A. Hey, you may get surprised, sir, such a small topic, easy. Yes, my dear children, that is what I said. Not only this unit, the entire chapter will be like this only. But dear children, I'm very sorry, we are not going to discuss the entire chapter in the single video. Okay, because I don't want my students to sit continuously hours and hours to read. No, you also need in between break. Okay, so this is what actually in today's class. In the next class, we will be talking about some laziness of the objects. You may wonder, sir, human beings have a laziness. How come the objects will have laziness? Yes, my dear children, that is called inertia. Okay, so in the next class, we will be talking about inertia, types of inertia, and Newton's first law of motion. Okay, dear children, till that time, thank you so much. Thanks for watching. All the very best.